Let's start with the lecture 4b, property of the pure substance, and again we will be doing some numerical and numerical related to interpolation. 3.44 in your book, a rigid seal vessel has a volume of 1 cubic meter which contain 2 kg of water at 100 degrees centigrade. The vessel is now heated. If a safety pressure valve is installed, at what pressure should the valve be set to have a maximum temperature of 200 degrees centigrade? The question is very simple. It say like we have got a sealed rigid vessel. Sealed rigid vessel would mean like the volume of the vessel would remain constant. The volume of a rigid vessel, which is actually over here, is 1 cubic meter of 2 kg. So that would mean like if we are looking for the specific volume would be equal to 1 divided by 2 kg. So that would be 0.5 cubic meter per kg of water, obviously, at 100 degrees centigrade. So the initial state of the water is 100 degrees centigrade. Now the vessel is heated. So heat is supplied to the vessel. If a safety pressure is installed, safety valve is installed, so we have to have a limit of the pressure. So what pressure would the valve be set to have a maximum temperature of 200 degrees centigrade? So in a simple way, it's say like when the temperature reaches at 200 degrees centigrade, while the volume remain constant, what would be the pressure P2? So in a simple way, what we have to do, like we have to find the final pressure, what we have to find would be the temperature T2 and volume V2. At that temperature V2 and volume V2, what would be the pressure P2 like? Simply, that is what actually the TV diagram would look like, and that is what it should say. So in a simple way, what we have to do is go to the steam table. At state number 2, we do not have anything to do with the state 1. That's what actually I can imagine. So at state 2, what we have to do is go to the 200 degree centigrade temperature, and we have to find out the volume. So first thing first, again, I said like initially, what would we say? What we have to do is go to the temperature table, a temperature saturated temperature table at a temperature of, let's say, 200 degrees centigrade. Uh, Let me clear this one for you people first. So at a temperature of 200 degrees centigrade, just check the value of Vf and Vg. So our own value is actually equal to 0.5 cubic meter per kg. So just check it over here. The value of Vg is obviously less than the value of 0.5 cubic meter per kg. So in a simple way, it means like we are in a superheated region. So now let's go to the superheated steam table, and table number, I think that is table number 6. Now let's go to this superheated steam table, and that is the value of 200 degrees centigrade. That's the value, and obviously we will be looking at the pressure over here. So just going down at 200 degrees centigrade and finding out the volume, which is equal to 0.5. So just going down over here, and just let me find it out, and that's say like if I would just look at it, that is the value which is somewhere over here. No, I don't think so. It's somewhere, yes. So that means like, yes, 200 degrees centigrade. So if I'm looking at this one, so this is the two values, the volume value. So one value is 0.5343 and the other value is 0.4736. That simply mean like our own volume, which is 0.5, somewhere between them two values. So at 0.5343, we have got a pressure of 0.4, and 0.4 megapascal, and a volume at a volume of 0.4736, we have got a pressure of 0.45. So we are our own pressure P2 would be somewhere between P1 and P2. Yeah, sorry, between 0.4 and 0.45. Now, as we have done previously as well, so just go to the interpolation thing, and that's what actually we would be looking at. Let's say if I say uh, just snap it from here. Let me add a new untitled pages and paste it over here. So what I'm saying, like, we will be interpolating between this pressure, this volume, and this volume. So just go to the lecture itself. So definitely it would be actually somewhere at a pressure of 431.3 kilopascal. That's the in kilopascal. In other words, if I'm saying like this, he has been what actually the book has done is actually interpolating between 0.4 and 500, actually 500 and 400, while we have got a steam table which is a little bit more detailed than them. So we have got a value at 450 and 400 as well. So we are interpolating between 450 and 400. So that's what actually I'm looking at, 450 kilopascal and 400. So this was the our first numerical, and we have got the pressure of 431 kilopascal. Okay. The next question is uh, water at 200 kPa with a quality of 25% has its temperature raised to 20 degrees centigrade in a constant pressure process. What is the new quality and the volume? So it is actually just asking us about the new quality and the volume of the water if it is the inside the vapor dome. So first thing first, what actually we have to do is find like what actually uh, uh, where we are actually. So let me find it like it at 200 kPa at 200 kilopascal at a quality of 25 degrees centigrade. So obviously the quality is given, the pressure is given. So if the quality is given, definitely we are somewhere inside the vapor dome. So that's what actually is already defined. So let's check the at 20 kilopascal, find the saturation temperature. So let's move to the saturation temperature, saturation pressure at 0.2. The saturation temperature is 120.1 degrees centigrade. So we have got a temperature of at 200 kPa, 25% quality, obviously that's inside the vapor dome. The temperature is 120.21 degrees centigrade. Now it's like its temperature is raised 20 degrees centigrade in a constant pressure process. So let me clear this thing for first actually. So if I've got a constant pressure actually, as you can see from these lines actually, these are our constant pressure lines. So if I've got a constant pressure and if I raise the temperature of that constant pressure, so definitely I have to move outside the vapor dome. As you can see, like at inside the vapor dome, let's say if I've got a pressure of 200 kPa, so it will remain constant. Obviously, that's what it actually say. But with this pressure, the temperature, which is actually saturation temperature, which is equal to 120.21, will also remain constant. If you can imagine from the previous lecture, the pressure and temperature remain constant inside the vapor dome. So if I need to raise the temperature inside the vapor dome, sorry, if I need to raise the temperature at 200 kPa, definitely I need to move outside and that would be outside in a superheated vapor region. So what I'm saying, like, if I would just say like the temperature would be raised to 20 degrees centigrade, so just add 20 degrees centigrade to it, so that would be 140.21. So we will be having a temperature 140.21 somewhere outside the vapor dome and somewhere in the superheated region. Now the next thing would be, actually we have to go to the superheated region at 200 kPa at 140.21 degrees centigrade. We have to find out the volume of the vapor. So that means, like, at 200 pressure of 200 kPa and temperature of 120 we have to find out the volume, which is actually volume of a superheat. So let's check. Yes, we are in a saturated region. So let's check the superheated table. So in a superheated table, let's move downward, and let's move downward to the pressure, which is 200 kilopascal, which is also equal to 0.2 megapascal. If you can check again, the at the in a bracket, it is 120.21, which is actually the saturated region. So now we have to look at the temperature, which is equal to 140.21, which is actually the elevated temperature. So yes, you can imagine there is no temperature of 140.21, so there is no column of 140.21 now. So obviously, again, in other words, you have to interpolate for that volume if you need to find out the volume at 140.21, which is actually the volume over here. In a simple way, if I'm saying, like, I just need to interpolate between this extreme volume, then I must also know this extreme volume as well to know the temperature. Sorry, to know the volume. In other words, if I'm saying, like, let me clear this thing for first. What I'm saying, like, if I need to find out the volume at 140.21, I must know these 2 points. As you can imagine, in a linear interpolation, I must know the extreme point. So if I need to find out the volume at 140.21, I must know the volume at this point as well and the volume at this point as well. In a simple way, the volume at temperature which is above than 140.21, it is one of them value is given. So you can check it. In a superheated region, we have got a value of 150 is given. So 150 is 0.9599. So I'll just go to the same phase diagram of say, like, so at 150 we have been given a volume of 0.9, sorry, for let me check it again, 0.9599, 0.9599. So just check it, like, what would be this volume then? This volume, because we need to interpolate between 150, some other one, and obviously to find out the volume at 140.21. As I did said earlier, that for interpolation we need to have two extreme values. If you can look at the figure itself, and I have drawn 2 points actually. One is this point and another is this point. You can imagine somewhere here as well. This point is 150 anyway. I've drawn the volume at 0.9599, and you can imagine this point is there. This point is at 0.2 megapascal, which actually is our pressure. And can you imagine this point would be the volume Vg? So what I mean to say, like, if I'm looking for the another extreme point, actually, I can have a volume which is actually at Vg at 0.2 megapascal. Go back to the steam table and let's check the steam table at pressure of 0.2 again, if I'm saying. So 0.2, we have got the at 0.2 we have got the temperature, which is 120.21, and we are looking for the value of the volume Vg, which is 0.88574. So I would know 0.885, sorry for that, 88574. So that mean like, and yes, if I can same from the same table, the temperature at this point is 121.21, which is actually the saturation temperature. So saturation temperature over here, so 120.21. So you can imagine what we are doing is actually interpolating between 150, 100 and 121.21, which was in the saturated table. We are interpolating between them two volume. So yes, again the same method, the same thing, we can find the interpolation between them two value, and we will be having a volume which will be 0.9354. This is what actually we have to do. It's like interpolate between the saturated, interpolate between the saturated and superheated region. Now that's what it's saying.